Okay, so here is your warm-up questions for today. This is the last sort of piece of information here, last section of Unit 6, and this is your last outcome quiz for Unit 6. So today will be a review day, but I wanted to go over a couple problems on how to solve radical equations, some examples here. Now these examples come from your review already, so when you get them done, you can sort of hang on to them, and then if you want to use them to complete your review, you can. Basically, with solving radical equations, we have to, step one is going to be to isolate the radical. The radical needs to be by itself. So unlike number 2 here, where there's a couple things that are on the outside of the radical, we have to isolate the radical first. Now the good news is, I'm going to just move this up here, so that's room. The good news with number 1 is the radical is already isolated, and since it's a square root, in order to get rid of the radical, we're going to square both sides. Okay, that will cancel out with the radical, leaving you with 5x minus 4 equals negative 6 squared. Negative 6 squared, negative 6 times negative 6 is 36. And then 5x minus 4 equals 36, so I have to just solve for x. I add the 4 over, add the 4, and I get 5x equals 40. And then divide the 5, and then divide the 5. So I get x equals 8. Now, one thing that I mentioned in class is that because radicals have restricting domains, meaning that there's input values that we actually cannot use because it makes the radical negative. Because it has restricting domains, we always have to check our solutions. Whenever you have a problem that has a restricting domain, whether it's a fraction or a radical, you have to check and verify that the answers are in fact accurate, or they actually can be used. So we're going to check and make sure that 8 is in fact a solution. And what you do to do that, okay, is there's 2 ways to do this. Here, I'll show you both ways. So there's 2 ways that we can check and see and verify that 8 is in fact a solution. For this first question, I will just show you one way, and then for number 2, I'll show you the other way, and you can do whatever way you want. So the first way to check whether or not something is a solution is to simply just plug it in for x and see if your equation comes out to be true. So we're going to check that first. So I'm going to plug in 8 in for x, and just to verify that this is, I get a true statement here. So I have the square root of 5 times 8 minus 4 equals negative 6. So we can verify this. I just plugged 8 in for x. 5 times 8 is 40, and 40 minus 4 is 36, so I have radical 36 equals negative 6. The square root of 36 is 6. So I get this answer of 6 equals negative 6. Now is this true or false? Okay, 6 is not equal to negative 6. Therefore, this is actually not a solution. And since I don't have any other solutions to check, this problem has no solution. Okay. Again, solve the radical. That part should be fairly simple. Solve the radical and get an answer. When you get an answer, it is important to check your work, because 8 doesn't actually work. I know it seems so weird that you solve for x and it should work, but it doesn't. One thing that you can notice up here is that I have a square root of some number giving me a negative number. If you went right from the beginning, there is no way in the world that I can take the square root of any number and get a negative. So that just sort of proves the point that it is no solution. Okay, so now let's look at number 2. So I can slide this over. There we go. Okay, so I have more room. This one, the radical is not isolated. So what I usually tell students, circle your radical, because that's what I need to get by itself. Everything else needs to go. So I'm going to start by moving the 7 over here, adding 7 So I get 4 cubed cube root of 3x minus 1 equals 20. Let's see if we can zoom in here, make it a little bit easier. Okay, now I just have to get rid of the 4, so I'm going to divide both sides by 4. So I have the cube root of 3x minus 1 equals 20 divided by 4 is 5. And now I'm just going to, since this is a cube root, in order to get rid of a cube root, we cube both sides. That'll cancel that out. Give me 3x minus 1 equals 1 or 5 cubed. 5 times 5 times 5 is 125. And then solve. Add 1. 3x equals 126. Divide by 3. Divide by 3. And we get x equals 126 divided by 3. It's 42. Now, just like the previous problem, we're going to check that this is in fact a true answer, and this is actually a solution. Now, this one again might be just easier just to plug in for x here and just see if it ends up working out like a solution like the first one. But if you want an alternative to this, sometimes you get really crazy answers. Let me zoom out here so you can see everything. Sometimes you get really crazy answers, and it's just easier to do the second method. So the second method is to bring in our graphing calculator, and in order to verify that a solution is in fact an actual solution, we're going to put the left side of my original equation into y equals and the right side into y equals. What should happen is, so let me show you. So I'm going to let me clear this out. Okay, what should happen? So I'm going to plug in the left side. This will be like a wall here. The left side will go in, so 4, and then cubic radical of 3x minus 1. And then get out of the radical there. And then minus 7. I can plug that into one of them. And then the second y equals will be 13. So when I go to graph these, what we're looking for is where these radicals cross. So the only issue is that because one of my equations is y equals 13, I need to zoom out. So I'm going to zoom out so I can see both lines. You should see 2 lines. There is one of them. Oh, and there's the other. Oh, they almost cross. I'm going to just trace here and see if it'll take me over. I'm just letting it take me over just a little bit so I can see where these cross. Ding, ding. If you hit the trace button, it'll let you do this. So it looks like there's where it crosses now. So I just need to find that intersect point, and I need to just check and verify that it does cross at 42. So if I hit second and calc and go to intersect and just hit that button 3 times, you'll see here that it does in fact cross at 42. So this is a solution. So I just wanted to show you both ways of doing it. The first way, I could have just plugged 42 in for x and just went through the whole problem and see if I got a true answer at the end. And then now to verify that that's a solution. Or you could put the left side in your y equals and the right side in your y equals and verify it that way by seeing where those 2 lines cross. And they do in fact cross at 42. So that is a solution. So there's a couple ways of doing it. I hope this helps. Good luck on your quiz today. And I'll see you on the test on Monday or Tuesday. Thanks.